Hello, my name is Arnstein Orten. I am leader of IT infrastructure at Met Norway, and I wish to talk about OpenStack for Operations and Community Cloud, what we do at Met Norway. So my agenda, I'll briefly go through our operations historically and a bit more on now. What's important to us, why do we do what we do, and at the end a short bit on the European Weather Cloud. But first, what is it actually that Met Norway does? Well, I can certainly tell you what we are known for. Yr.no, that's the world's 5th largest weather site. That's pretty cool for a small Norwegian state organization. At the back of this slide is a heat map of Yr usage around the world. And we are also quite known for being the first to bring free and open weather data to Europe. And I absolutely love open data. But that's still not our mission. We safeguard lives and values. How do we do that? Well, we provide weather forecasting services, especially extreme weather forecasting services. We give people climate data that they can rely on, and we also do research. Now, how do we do this? Well, of course, we do it through services. These are 4 example services. At the far left, we have an ocean drift model that we typically run if there is an oil spill, for instance. At the top, we have a data distribution service called Threadsmetno. I'll come back to that later. At the right is a lightning monitoring service. The underlying service is very important, especially for aviation and stuff like that. And at the bottom, there is an air quality service. And this runs on infrastructure, of course, important infrastructure. So I want to go back in time a bit, back to 2014, before my time, but then we were running on KVM. Our storage solutions were proprietary, and all our HPC was outsourced. So we did have high availability solutions, but they came at a financial cost. There was little self-service and, unfortunately, also a feeling that we were not moving fast enough. So the plan was to go for OpenStack and Ceph. We wanted to provision these systems with Chef on Ubuntu servers. Now, way back in 2015, Ubuntu didn't give us the performance that we needed. And we were not able to get what we wanted out of Ceph. That might be our problem. Perhaps we were simply not good enough with Ceph. But when we went into production in January 2016, this is the technology stack we used. We had OpenStack, we had Ceph. We used Consul and our own bash scripts to provision these systems. We provisioned on top of Docker Swarm and CentOS as the operating system. A pretty good system. We used it for a number of years. So before I go to the technology stack that we use currently, I want to talk a bit about the infrastructure we provide for our users now. If you see this person on the left here, internal user, that could typically be, for instance, one of our researchers. She's able to run high-performance computing jobs on our in-house PPI HPC system. This system is closely coupled to our 30-petabyte Lustre data store. She can provision services on top of OpenStack or on top of Kubernetes. Typically, those services will also use data from the Lustre data store. Now, this gray guy on the other side, external user, could be an external scientist, could be someone working for some of our partners. He can actually do pretty much the same. He can provision virtual machines on the European Weather Cloud. And he can run jobs on the PPI external HPC facility, again, tightly coupled to our external Lustre storage facility. They can all use the object store. So really the only system that we don't provision to our partners is our Kubernetes. This is an example service, Threads. It uses the the Threads data server software to publish data in netCDF format, typically gridded data, time series data, and it spans our infrastructure. This is a free service accessible by all. So if you wish to set up a weather forecasting service, you can do so. You don't have to pay us any money. You can just use our data. Totally fine. And people do that. We see that in our logs. But if you want an SLA, you will have to pay us some money. So the way we do this, as a consumer, you go through a load balancer implemented on our Kubernetes cluster. It will send you to the virtual machine with the least amount of things to do, and you will get served data from our Lustre data store. If you have an SLA, of course, you go directly to the virtual machine that is set up for you already. So this is a very cost-efficient way of implementing a service which serves quite a lot of data. So pretty happy with it. This is a technology stack we currently use. Again, OpenStack, Ceph. We used to provision with Puppet OpenStack. These days we use Kolla Ansible. Pretty happy with that. Regardless, we automate with Ansible and GitLab CI/CD for pretty much everything we do. As I mentioned, Kubernetes, Lustre, and everything running on Red Hat Enterprise Linux. So these are some numbers for people interested in that. Our 2020 cluster is still running. Fairly happy with it. SSD block storage with Ceph, and also object storage based on Ceph and based on Puppet OpenStack. The European Weather Cloud cluster is the first cluster going into production with us, which is based on Kolla Ansible. And our new main production cluster will be based on exactly the same as the European Weather Cloud setup we have. So, infrastructure, what's important to us? Well, first of all, we need to have something worth delivering to people. And after we have that, we need to make sure that it works. So that's sort of the point here. So having something at all, we need services close to our data. We need to make, it needs to be easy to go from science to operations, and there's also a cost component. So with the data first, data has a sort of gravity. If you have a lot of data, you need to implement your services where that data is. So these are our internal data sources. We really have very good data on the Arctic. And when we run our services, we typically use our own data, but we also take in a lot of other data sources, bring them to our data center, and deliver services there. I'll come a bit back to that later as well. But having data, important, and the data needs to be where the services are, or the other way around. When your researcher has made something worth having, it's important that it's as simple as possible to put that into production. So the way we do it, we have one infrastructure, we use it for research, and we use it for operational needs. So putting things into production could not be easy from an infrastructure point of view. It shouldn't be difficult. If you have it, just put it into production. And then cost. We are funded by the state, so we don't have a lot of money, and it's important that we use the money that we have in the best possible way. People say that public cloud is cheap. Yes, that is sometimes true, but if you run a lot of very large computing jobs, so you sort of use your processing all the time, and you have a lot of data, I mean, those are not resources that can be shared. So public cloud isn't so cheap in those matters. Our costs are competitive, and that is also why we run our own infrastructure. It gives us the most services for the money. So I could probably have other things in this list, but I wanted to talk a bit about this. So yeah, call it operational requirements. First of all, competency. yes, of course, you need to have good people. You need to give them the correct training, stuff like that. I think one thing people often don't think enough about is focus. When you have tools that work for you, tools that you love, you need to make sure that you use those tools for what you want done. Puppet worked fairly well for us. I had a couple of people who were great with Puppet. Everyone in my team is great with Ansible. So whatever we do tomorrow, we do it with Ansible, and we do it with GitLab CI/CD, and it's going to be great. And when I lose the people, 1 person, 2 persons, it will not matter because we are still great with GitLab and with Ansible. Service metadata. People often find this boring, but it's really, really important. The way we do it, all our services are defined with TOML files. That's a sort of YAML-like language. So every service has its own YAML file containing info on stuff like who is responsible for the service, operational level agreements, terms of service, privacy information. We are in Europe, GDPR. Dependencies, it has integration hooks for service management tools, etc. And when you do changes to the repo, you trigger a CI/CD website rebuild, you know all that stuff. That's not important. But I do wish to show you snippets from these TOML files. This is the OSTAC service, or the OpenStack service. I own it. Marius is technically responsible for it. Dependencies, that will give us a dependency graph. We have a hook into monitoring. That will give us hierarchical monitoring. Further down in the file, my people are not lawyers, but my people are really great at putting machine-readable config files into Git. So that is what we ask them to do. This is a machine-readable config file that gives you GDPR. So what comes out of it for me as the owner of the service? I get great human-readable service descriptions with operational level agreements, all the good stuff. Our lawyers get GDPR information specific to each service that they love. I get dependency graphs. I don't expect you to read this, but on the far right we have the OpenStack service. Then we have some services dependent on it, and on the far left it's sort of user-facing services like extreme weather warning. So, okay, if OpenStack falls down, it's going to be bad. That's obvious, but we have this for all services, and it really is nice to know that if I have a problem with that specific service, what's impacted. You get that for free if you have these dependency graphs. A bit on redundancy. We have 2 primary data centers. They don't share infrastructure apart from the networking side. They share it in the way you can see in the drawing here. This has not been a problem for us. I'm pretty happy with that. And when we implement services like OpenStack, we always implement it in a way that it's easy for people to implement their services in a way so that if we take one data center down, it's not going to be a problem for them. And this is also part of, call it the cost-saving bit. If your service is important to you, you make sure that it can run with one data center down, and that makes our job much easier. At the top here, secure zone, Ansible, out-of-band. I'll come back to that in the next slide. Contingency. In practice, our contingency is infrastructure as code. We did the server configuration management with GitHub and Ansible, like I've mentioned. Everything automated through GitLab CI/CD from this secure network zone. This network zone is very secure. Physical access keys and YubiKeys. Authorization procedures in place. We are ISO 27001 certified. Peer review of important changes, of course. As I mentioned earlier, OpenStack configuration management with call Ansible. if I need a new OpenStack cluster setup, it takes us half an hour, and then we have it already integrated with the rest of our services. Provisioning solution, Cobbler, not really that happy with Cobbler. We are test casing doing it with Ansible. Again, use the tools that you love and that work for you, but we'll see what happens. If you're interested in how we do automation, please go to GitHub. All our Ansible playbooks and roles and stuff are there, so look around and use it if you find it useful. So, over to the European Weather Cloud. Now, we have had really good presentations on the European Weather Cloud on Open Infra Summit earlier. These are probably the three best. Vasileios Passois and Charalampos Kominos of the European Center for Medium Range Weather Forecasting have held those talks, so go and check them out. I have borrowed a few of the slides just to give you some idea of what we are talking about. So the European Weather Cloud, it aims to become the cloud-based collaboration platform for meteorological application development and operations in Europe. I'm pretty certain we're going to get there. Talk to me in 2 years. I have high hopes. It is a cloud like you would expect. I mean, most of you are OpenStack people. It has stuff like isolated cloud tenancy, virtual machines, block and object storage, virtual networking, resource management. Again, the stuff that you would expect from an OpenStack-based cloud. Morpheus is chosen as the cloud management orchestrator. This is a very old slide, but it was from when we did the proof of concept together with EUMETSAT and ECMWF. You see on the cloud orchestration layer, they are both running Morpheus. We are not. We are just slotting into their Morpheus setup. So Met Norway and the European Weather Cloud, we did a proof of concept integration with both core partners in 2020. And currently our European Weather Cloud is in production. It is integrated with EUMETSAT's operational European Weather Cloud. And ECMWF is coming any day now. But why should I care about the European Weather Cloud? I provide great infrastructure for my users already. Now that's true, but we do get things from the European Weather Cloud that I cannot give my users alone. The most important is distributed services. What we currently do, we have great data on the Arctic. So when we run our weather models, we typically take a large chunk of data from ECMWF, bring it physically to us here, and run our weather forecasting models on that shared data. And we do that kind of thing for a lot of different things. It's not the best way of doing it. With the European Weather Cloud, I could typically have a small service running on ECMWF beside the massive data store that they have there, extract the data I need, bring that data back to our data store here, and then do the rest of the service delivery from there. And also opening our infrastructure to partners. Again, I already have people running on our infrastructure, but I don't wish to give them only the possibility of running virtual machines close to our data. I wish to give them the same possibilities that we have, so that if they need data that the ECMWF have, they run parts of the service there. If they need satellite data, they run parts of the service on EUMETSAT. And then contingency. If we totally lose ECMWF, we could probably continue delivering with data from NATO, for instance. What if we totally lose ourselves? It would be nice if parts of our services were already running on ECMWF. But yeah, discussions for the future, but it certainly gives us possibilities that we don't have alone when we have this possibility of sharing compute resources between us in this way. I wanted to show this to you as well. Again, it's back to what I said earlier. On the far left, you have, first of all, this is how we give data to people. And again, I mean, we have a lot of people who go to us, get a large chunk of data, put it in their own data centers, and run some kind of service on it. Again, it's not great. On the far left here, we have the PPI external, the HPC solution that we already have customers using. That's great. They can use the Lustre data store and run their jobs. On the far right, the European Weather Cloud. Again, you can run virtual machines close to our data. So you don't have to get all the data. You can extract the kind of data that you need and bring that back if you need it. The use case I'm working on presently is together with the Norwegian Directorate for the Environment. They wish to run a remote sensing service. They wish to have it on Norwegian soil. And they need to be close to the kind of data that we already have. So yeah, we can help. And then we'll see what happens with other use cases down the road. Any questions? Thank you so much.